Hey guys, welcome to Precalc. Let's go straight into polar functions. Polar functions are a bit weird compared to our typical, A and B, X and Y, A and B, I and J, like all that stuff. And really that's because they revolve around two things. They revolve around an R and a theta value. Here, R is really, I guess, the X. Wait, am I switching this up? Yes, I am. No, I'm not. It is r theta. And r is really kind of like a magnitude. And theta is the, I guess, direction of the magnitude, like a vector. Please don't lag. There we go, direction. When graphing a polar function, firstly we need to be able to identify our functions. The easiest one I believe to identify is a rose curve. The rose curve ends up making petals, and the function often looks like we'll have amplitude times cosine times cosine of n theta. That is usually just the rose curve. The A is the amplitude or petal length, and the cosine is the cosine, and or really the sine as well, really just lets you know whether or not petals are on or off the quadrant axes. The n here helps with the number of petals. If n is even, then there are 2n petals. If even, 2n petals. And then if odd, there are n petals. An example of an equation I could say is 3 cosine. Let's use sine instead. 3. Why is this lagging so bad? Sine 4 theta. Here, if I were to graph, we know that sine never starts at a max and it starts at 0. So we're never going to be touching these chords, as these chords represent 0 or 2 pi over 2, 3 pi over 2, and pi over 2. And let's start. We know sine of theta at 0 equals 0. So 3 times 0 is 0. We're going to start at 0, 0. If we go to pi over 2, we know that at pi over 2, sine is equal to 1. So then we end up forming our first petal, which kind of goes off this. Let me make this look a bit better. It's about here. It graphs in this order like this. And the height of this is actually 3. That is where that is. Now let's look at going towards pi. We end up decreasing, and we're really able to see that with I'm so sorry, it is pretty late. We're able to see that with our next graph, and here sine is still positive, so we continue to be positive, and we end up growing a third petal in which we start at a max of near 3, and we drop down to 0. Now once we go to the next quadrant, we get I'm sorry, we're at 3 pi to 3 pi over 2. Here, sine is negative. So what ends up happening when you're negative in a quadrant is that you don't stay in that quadrant. Like here, you wouldn't do that. You end up going to the opposite quadrant because that's their way of going negative, because you would be negative there, and you end up drawing your next pedal. Then what ends up happening after that is you're still negative in the next quadrant. You draw this pedal, and now you'd end up repeating this process again due to the fact that it's 4 pi, and you'd be left with 8 pedals. I do not have the time to fully draw this out. If I were you, I would recommend drawing out this graph normally and then seeing the intercepts and basing pedals off of that. Because really the pedals, they're kind of like the top, like this area that I'm shading in of a regular graph, except represented in a new axis. But that is how the rose curve works. Let's go into the next one, which I believe seems to be easier to understand, and those are lime suns. I think that's like how the accent is. Lime suns. They follow the format of a plus b cosine or sine theta. This can be plus or minus. What ends up happening here is you can actually figure out what kind of limestone you're really working with pretty quickly. When you have, if you divide a and b and that is less than 1, you will have a double looped limestone. When a of b is equal to 1, you get a special case of a cardioid. It's called a cardioid because it looks like a heart, and I think they're pretty cool. They kind of look like this. I'll actually draw these graphs for you. It'd be like this, like it'd be a round heart. That looks pretty ugly. If I had that heart, I would not be alive. Let's draw this out, kind of like that. A double loop limestone will start out high, cut down. I really cannot draw. There's a reason I prefer math over art. If we were to start here, we go up here, boom. And then wherever the max of y is usually in the opposite direction. You'll have like the loop. Really, the loop kind of protrudes more, like it looks like there's a dent. I'm not unable to draw that right now, my apologies. Next, when a over b is greater than 1 but less than 2, in that case you'll get a dimpled limestone. These are a little ugly. I don't really like these. Actually, I'm just hating right now. They're pretty cool. When you draw it out, it's nearly a circle, but it's like there's a small peak there, and boom. So it's not like a heart. Like the heart is like a heart. This is more or less just like a little imperfection. And then when a over b is greater than 2, you would just have a convex limestone, which really just looks like a circle. Like it's hardly like imperfect. That's the gist of it. Cosine is symmetric over the x because it's odd. So it's a symmetric x. I know I spelled that wrong. Sine is symmetric over the y because it's even. For circles, I don't think you're going to be seeing lots of circles. Circles are simply just a times cosine or sine of theta. This is an attempt of drawing a circle. Very off. And finally, spirals, which I also do not believe you'll be seeing, are actually equal to r theta. These are pretty cool. I'm a big fan of these. And I mean r theta, I mean r equals a theta. A what? I'm I'm just writing to write right now. R equals A times theta. Spirals are pretty cool. In order to identify spirals, you should be able to divide points up the spiral. So if you see like 3 2 pi and like 5 4 pi, if you were to divide, you'd see that you'd be able to identify points. That's just the gist of it. And these continue to increase as they go outward. If you want to understand these more, I can draw a spiral for you if you'd like. I kind of just feel like drawing. It kind of look like this. If you're more interested in understanding how these really look, I don't think they'll be coming up a lot in Precalc at all, but you can always Google it and watch an organic chemistry tutor video. That is all. Have a great day. I hope you understand polar a bit more.